Welcome back. I'm going to show you how to run a linear regression in M+. So this study was about health as an outcome of personal fulfillment and professional fulfillment. The names of the variables in our dataset were health, professional fulfillment, and personal fulfillment. And in the model section, we specified two regression paths, one from professional fulfillment to health, and one from personal fulfillment to health. Remember that in order to specify a regression path in M+, you always have to say outcome on predictor. The outcome is regressed onto the predictor. Now you will remember that when we ran this model, the estimator that M+ used was ML. So let me show you quickly. If you save the model and press run, you now get the output file, which was opened on top of the input file. So if you scroll down a bit, at some point you will get this line here, which says that the estimator was ML. Now what happened is that this is the default estimator when your outcome variable is continuous. So what M+ actually did is it included this extra command, analysis estimator equals ML. So if I save this model and run again, you will once again see this here. So now you have run a linear regression. You had two predictors and one outcome, and you can scroll down to see the result. In fact, because this is a continuous outcome, it's often very helpful to look at the STDYX standardization. Because what this means is that the regression coefficients here can be interpreted with regard to their strength. So because these numbers can only range between 0 and 1, or 0 and -1 if it's negative, you now know if this is a strong coefficient or not. So for example, the relationship from professional fulfillment to health has a strength of 0.524 and is significant. So you'd say that's moderate to high. The relationship from personal fulfillment to health is also significant, but it's a little bit weaker, just 0.374. And then you also have information about the intercept. So this is the intercept of the regression path, and it represents the level of health you would have if the predictors were both 0. This is because in regression, you want to know how much health would be increased as an outcome of heightened professional and personal fulfillment on top of what the level of health would be otherwise. So here you now also have the residual variance, and in its standardized form, it represents the proportion of variance left unexplained by the two predictors. So the two predictors did not explain 57% of variance in the outcome. If you scroll down further, at some point you will get the R-square. This is the counterpart for the residual variance. So the residual variance tells you the proportion of variance that is left unexplained by the predictors. In contrast, the R-square represents the proportion of variance that was explained by the predictors. So in this case, this is 43%. This is it with regard to linear regression. I'm going to show you now how to do it when your outcome is skewed and when your outcome is both skewed and contains missing data. So stay tuned for the next part.